Hi students, I'm Sourabh Singh from IIT Patna. I am associated with askIITians for the last 5 years as an associate consultant in-house expert in mathematics department. Today I am doing a session which is on limits, continuity and L-hospital rule. In this session I am going to deal with the various subtopics, their definition involved and their physical meaning with which we relate them to the physical world, which is also a very integral part of all the engineering examination that is held in our country. So this session is basically divided into 5 subtopics which will conclude the parts like limits, one-sided limits, infinite limits, finding out limits, L-hospital rule and continuity. So the first session goes in which we will take the definition of limits and what do we mean by limits. Once there was a child and he was so sad. So his mother came and asked, "Why you are so glum?" So the child replied, "I thought the teacher said she was going to limit our homework, not give us limit homework." So I think the child was not very interested in reading maths as well as limits, but we are, so we are going to deal with limits and continuity. In this chapter, we learn about limits, finding out limits, one-sided limits, infinite limits, and continuity. So let's start with this. The very first is limits. The word limit in English meaning that is used everyday conversation to describe the ultimate behavior of something, as in the form of limits of one's endurance or the limit of one's patience. Similarly, in mathematics, the word limit has a similar but a more precise meaning. So let's see what do we mean by limits in mathematics. Suppose you have been given a function fx, and if x is approaching 3, causes the function to take values approaching or equaling in some particular number such as 10, then we can call 10 as the limit of the function and will write it as limit when x tends towards 3, then fx assumes the value of 10, so limit of fx as x approaches 3 is 10. In practice, the two simplest ways by which you can approach 3 are either from the left hand side or from the right hand side. So let's see how do we approach towards limits. For example, the number 2.9, 2.99, 2.99 approach the numerical value 3 from the left, that is denoted by x tending to 3 minus, and the numbers 3.1, 3.01, 3.001 and so on are approaching 3 from the right, and that is denoted as x tending to 3 plus. Such limits are called as one-sided limits, and it is explained in the figure also. See, if you are approaching 3 towards the left of the number line, then it's called as approaching from the left, and if you are approaching number 3 from the right hand side of the number line, then it's called as approaching from the right. The left hand side limit is described as x tending to 3 minus, and the right hand side is described as x tending to 3 plus. So let's take an example in which we will find a limit by using tables. So from the use of tables, we have to find out limit of 2x plus 3 as x approaches 3. So how do we find the solution? Suppose we make two tables as shown below in this figure, one where the value of x is approaching towards the left hand side and other the value of x is approaching from the right hand side. So the first table signifies the values where we are approaching towards 3 from the left, and the values that x is going to take is 2.9, 2.99, 2.99. As this is a polynomial function, what we are going to do, we are directly going to put the values inside the function. So for x equal to 2.9, the function will give me a value 9.8. For 2.99, it's going to give me 9.98. For 2.999, the value of the function comes out as 9.998. So we can see a trend that this value is approaching towards the numerical value of 10. So this table shows that if we are approaching towards this function from the left hand side of 3, the value that this function assumes is 10. So let's check whether the same value is being attained from the right hand side. So if I'm going to approach from the right, the value of x will come out as 3.1, 3.01 or 3.001. And if we are going to find out f of x for these corresponding values, we will see that the values comes out as 10.2, 10.02, 10.002. So in this case also, it is very simple from this following values that the limit is approaching towards the value 10. So this table shows that if we are going to approach from the right hand side of the 3, the value of this function is going to be 10. Now there is very important thing that we should assume while finding out limits. the question says, and what we have found out with this is, when we are approaching from either left hand side or the right hand side, the value of the function is coming towards 10. Therefore, we can write as limit when x tending to c, fx is giving me a value L as explained in this curve, or it's also written in the format when x tends to c, then the value of fx tend towards L. In more precise way, you can say that if the functional value of fx is close to the single real number L whenever x is close to but not equal to c on the either side of the c. Next, the table shows that fx is doing as x approaches 3, or we have the limit of the function as x approaches. We write this procedure with the following notation. When the value of x is approaching towards 3, the first 4 values which are written shows that we are approaching towards the left hand side. The next 4 values shows the values which we have obtained while approaching from the right hand side, and this part of the table shows the different values that function assumes when we are approaching towards 3. And it's also visible from this table that the values that this function assumes when we approach towards 3 is more or less equal to 10. As you have just seen, good news is that many limits can be evaluated by direct substitution, which means that whatever be the given value of x, we will directly put it inside the function and find out what is the value of function, and that will be equal to the value of limit. So students, in the first part, we have learned the basic definition of limits, what do we mean by limits, and how do we see whether a limit exists or not. In the second part, what we'll do, we'll try to see the different methods with which we'll find out the value of limits.